I'm Yusef. I'm senior software engineer working for Delivery Hero. And I'm former C++, Java, PHP, Python developer. And since 2019, I have switched to Golang. I mentioned that because I have the reason, because of the topic that I'm going to present today is a topic that I've been facing in lots of those concurrent programming language that I used. So we are going to talk about the race condition in a Golang. So what is the race condition? Race condition is happening when concurrent operation outcome depends on unpredictable timing leading to unexpected behavior of the program run. What that means? Let's just give you a sample. We have a sample code here in the left side. 2 Go routines plus the main Go routine. One of them is going to change a balance, a shared variable. Another one is do adding. Another one is going to increase that. What we should expect it to be printed at the end of the program? 120, 90, 80, 100. So actually, all of them could be possible because we have known deterministic results. All of them could be possible because most of the time data arrays are introduced because the developer thinking of the problem like a sequential or consider the right operation as a atomic operation, because in concurrency, non-atomic operation could be interrupted by another Go routine. So how we detect how do we detect the race conditions? Because Golang is one of the programming languages that introduced and famous with this concurrency. How we want to detect this data race and race condition in the code. Hopefully, there is a built-in tool, dash race, whenever you want to run, whenever you want to build, test, and even install a package, you just need to pass this dash race, and it detects some race condition in the code level. It is a tool that has been based on, it's a C code. It's using the CGO to use some C-based functionality to detect this race condition. But of course, like anything that brings some runtime detecting has some drawbacks for us. One of the most one is that runtime overhead. In a very usual programming, in a usual program, it's bring us 5 to 10 times in terms of the memory, and 20 times in terms of the execution time more than often running. And another thing is that it does not guarantee detect all the race conditions. I have a sample here for you. Simple code, a slice, trying to change it into Go routines. First, second, third, fourth run, there is no race condition detected but dash race, but in the 5th time, boom. You can see that the race condition warning has happening. So what we should do? Actually, instead of that trying to detect in the running time, let's prevent it happen. Like the other problems that we have, let's prevent it to happen in the code level. First thing is that we know that the non-atomic operation could be interrupted by another Go routine. What can we do is just, in some cases that we want to have a shared variable, use atomic functionality that has been built in a Golang. It's available for some basic primitive types. Let's use them. So it will be sure that during the calculation, during the changing the variable of that atomic type, no Go routine interrupt the running of the process. Second thing is that when we have a shared resources in the programming level, detect them and create a critical section. So critical section is a very broad topic that we need to be aware about that. In critical section, when we have a shared variable, shared resources, we just prevent the Go routines go inside one, prevent Go routines go inside together, just let them go inside one by one. So there are some tools that unfortunately is not loaded. Yeah, it's not loaded here. So there are some tools like, first of all, Mutex. It's an old tool that it's happening all other programming languages like C++. And based on top of that, single flight, do once the other things that has been created on top of the log that let us to create this critical section in our code level. And the last and important ones, based on the Rob Pike famous quote, don't communicate by sharing memory, share memory by communication. Actually, in channels is a very, very good specific tool that has been created in a Golang. It's created for communicate by the Go routines with the with pathing the variables together and without any concern about the data race condition within the that channel. So if I want to create a conclusion of my talk, so first of all, think concurrently. As a developer, think concurrently. Every write operation in the code level could be interrupted by another Go routine. Be sure about that. When you have a shared variable, shared resources, be aware about that. Second is that create critical sections. When you have the shared things, create critical section. Don't let the Go routines together go inside the critical sections one by one. Of course, there are some topics that you need to provide that critical section, like that there is no starvation, there is no live log, and etc. But and the third thing is that use primitive Golang synchronization more. I mean channels. Channels is a specific Golang tool that has been created to work with this great Go routine concurrency. And at the end, thank you very much. It was really very broad topic that I could give a very whole talk. But if you had further questions, you can find me in the Delivery Hero booth. Thank you, everyone.
Thank you.